Now quotient rule. Now we are having two types of rules here. Number one is for the single function. Now let's drive first for the single function and operate the result. Now let gx be a single function, then d by dx of 1 upon gx, because it is quotient rule. Okay, 1 upon gx is equal to negative for derivative of gx upon square of gx, where gx is not equal to 0. Okay. Now let gx be the given differentiable function. Okay. Now let fx is equal to 1 upon gx, then fx plus h is equal to 1 upon g x plus h. Now by definition of derivative, d by dx of 1 upon gx is equal to f derivative x. We can write it f derivative x, and f derivative x will be equal to limit h approaches to 0 f x plus h minus fx upon h. Okay. Now f derivative x is equal to 1, sorry, I forgot to put the limit. Okay. Then limit h approaches to 0, 1 upon g x plus h minus 1 upon function of x g upon h. Okay. Now taking LCM, limit h approaches to 0, gx minus gx plus h upon h times gx plus h gx. Okay. To this, what we can write it now? F derivative x is equal to limit h approaches to 0. Now gx plus h minus gx upon h, and this whole with the negative part, like this. Okay. Because I have just altered the terms, times limit h approaches to 0, 1 upon gx plus h gx. Okay. Now this becomes negative of g derivative x times 1 upon gx with gx. Now what changes we have done it now? By definition of derivative, limit h approaches to 0 upon h is g derivative x, and limit h approaches to 0 x plus h is equal to gx. So, we have used these two things. Okay. Is equal to negative of g derivative x upon gx whole square, where gx is not equal to 0.